Percents, rates, ratios, and proportions. This video will take a look at how they're similar and how they're different. What is a percent? Strictly, if we talk about a percent, it is a fraction where we have a denominator of 100. For example, if we had 1 part out of 100, that would be 1%. If we had an uneven number of parts, maybe 12.5 parts out of 100, that would be 12.5%. And there's even cases where we can have more than 100 parts out of 100. Let's say we have 204 parts out of 100. Well, that would work out to 204%. Percent really just does compare the proportion of what you have to parts out of 100. And so if we take a look at these examples, we've got the letter S and the letter L making up some of the boxes in a 10 by 10 chart. Now because it's 10 by 10, the entire number of boxes in the chart is 100. And if we take a look at the number of shaded boxes that my L takes up, we've got 2 by 10, so there's 20 parts, 22, 24, 26, 28, 30, 32, 34, 36 shaded cells making up my L. The fraction of all cells, well, there'd be 36 parts out of 100. And of course, we wouldn't leave that fraction because it's not reduced. And if you took 4 out of there, that would be the biggest number you could pull out of a 36 and 100. But if you didn't see that, you could simply start reducing by 2's because they're both even numbers. Dividing out a 2 leaves me with 18 out of 50. And then we'd look at that and say, oh, that's an even number as well. So if we divide out another 2, 9 goes in there twice. And how many 2's in 50? That would be 25, and we get to a fully reduced fraction. So we have 9/25 is the same as 36 out of 100 to compare the parts out of the whole for the letter L. If we talk about that as a decimal, if we had 36 parts out of 100, that would be 0.36. And of course, we multiply by 100 to get to percent of all the cells. And so that would be 36%. The L, the shaded L blocks, take up 36% of my entire chart. So at this point, pause the video and do the very same thing with my S from my chart. It's still a 10 by 10 chart. And then start the video back up and check your answers. Okay, we can convert from fraction to percent to decimal and back and forth. If we are given 1, we would be expected to be able to find the other 2 parts. So if I have 25%, my fraction would be 25 out of 100. And we could reduce that fraction by dividing 25. There's how many times does 25 go into 25? That would be once. How many times does it go into 100? And so we get a reduced fraction. A quarter means the same thing as 25%. And dividing by 100 would get me my decimal. 25 parts out of 100 is 0.25 with my 5 in the hundredths column. 13 parts out of 100 would be 13% and 0.13 with the 3 in my hundredths column. If we had 12.5%, we saw earlier that that would be 12.5 out of 100, and as a percent, changing to a decimal, we would move that decimal places 2 places to the left or divide by 100 to get 0.125 with my 2, my whole number out of 100, the 2 landing in that hundredths column. If I had a decimal of 1.05, that can be changed to 105 parts out of 100 because that 5 lands in the hundredths column. And if we divide 5 out of there, there are 21 5s in 105 and 20 5s in 100 to reduce that fraction to 21 over 20. And then taking this as a percent, 105 out of 100 would be 105%. Sometimes the wording of questions is a little bit odd. If you see this wording, what percent of 20 is 15? What this is saying is I have 15 parts out of an entire number of 20, and we want to know what percentage does that 15 make out of the 20? What percent of 20 is 15? So my 15 parts out of 20, if we were to take that to a percent, we want it as a fraction over 100, and so I would be multiplying by 5 to get to 100, so I need to multiply by 5 to get to my value out of 100, and 5 15s would be 75, and so we would have 75%. Some of you may have looked at that and said, well, that's not a reduced fraction. So if we take a peek at my 15 over 20, I can take 5 out of there. If I take 5 out of the 15, I've got 3. 5 out of my 20, I've got 4. And 3/4 we often recognize as a decimal 0.75. And then, of course, if I have 0.75 as a decimal, I would multiply by 100 to get to my 75%. Either of those ways would be a great way to get to the percentage. If we take a look at a couple of practical applications, a retailer bought a sweater for $50 and marked it up by 20%. What is its selling price? This is a case where a retailer will increase the price so that they can make a profit on the sweater, and there's two basic ways to figure this out. First, if we want to figure out the markup value, I would take my original $50 and multiply by 20%. Now, 20% can be represented as 20 out of 100, and 50 over 1 if I needed the denominator. And here we can pretty easily reduce our fractions here. 50 goes in here once and in here 2 times. And then I would have 20 over 2, which would be 10. And that, of course, represents my $10 markup. If I want my selling price, I would simply take the original $50 that was paid for the sweater and add in the markup price to have a $60 price for that sweater. Now, if you don't like doing things in 2 steps, there would be a quicker and easier way to do this in 1. If we wanted to, we could take our $50 and if we multiplied by 1, then that would get our $50 in the selling price. And if I want to know how to find my 10 in there as well, if I was to multiply by 0.20, that is my 20% markup, and 50 times 20% would result in my $10. But if I multiply both of them together, multiplying by 1 to get my 50 in my final answer, and multiplying by my 0.2, 20%, to get the markup in my answer, I would get my $60 right away. So let's take a look at another one. An iPod regularly sells for $149, but students get a 7% discount. What is the selling price with tax? Of course, in Ontario, we have a 13% HST tax. So we want to take our 7% discount off of our $149 regular price and then put the tax on our reduced price. Now we can do this in pieces. If we figure out our discount, we would have $149 times our 7%. So that would be $149. Now I could multiply by 7 out of 100, or I could multiply by 0.07. And this kind of question, we would generally work with a calculator. It would make it a little bit easier. And we would find that that discount, 7% of my $149, would be $10.43. If I want to figure out my selling price, or sorry, my discounted price, I would take that $149 and subtract my $10.43. And when we do that, we find that we would have $138.57 for my discounted price. If I want to know the tax on my discounted price, I would take my 13%, my $138, multiplied by my 13%, which means that I've got $138 times a 0.13, or 13 over 100. And the tax on my $138.50 price, I believe, is $18 and is it 4 cents? $18.01? My goodness, I can't read my own writing. And I don't have a calculator. So let's fix that real quick. Forgive me, bear with me here. .013 times 138.5. Oh, there's the problem. We get 18.005. And so if we were charged that cash, they would, of course, oh, sorry, one too many zeros. They would round that up to a penny. And so 18.01. And finally, the final price of the iPod, I would take my $138.50 reduced price, add in my 1801, and I would find that I would be paying $156.51. Now, there is definitely a faster way with fewer steps to get to that $156.51. Again, just like we did our increase of 20% with one calculation, we could do our discount of 7% with one calculation. If I have a discount of 7%, that means I'm paying 93% of the price. And so if I take my $149 and multiply by 93% of that price, or $149 times a 0.93, I can get to that $138.57 right away. Instead of finding the discount and subtracting it, I can figure out the percentage that I'm actually paying rather than figuring out the discount that I get off. And then my tax, I have my $138.57. Again, I'm going to multiply by 1 to get that $138.57 in my price, and I'm going to multiply by a 0.13 to represent the 13% increase in taxes, and I will get to my $156.51 right away. Okay, over the page to ratios. If we talk about what is a ratio is simply a comparison of two or possibly more numbers that can be written in three forms. Now, usually if we have multiple forms, we're usually talking about a ratio of two numbers, but if we are in ratio form, sometimes we can have more than one number or more than two numbers. So, in words, we would say that this is 2 parts to 3 parts, or we could simply shorten that 2 to 3, 2 parts to 3 parts, and we would show that with this symbol of this sideways dot dot, the colon, 2 parts to 3 parts. In fraction form, we put that first number on top, 2 parts to 3 parts. And we have 3 ways to represent a ratio. If we compare 4 parts to 7 parts, perhaps we've got a recipe that we're making and we need 4 eggs to 7 cups of flour if we're making a great big recipe. Well, we would represent that with 4 parts to 7 parts, or 4 over 7. If we had a fraction 7/15, we could go backwards here and say we've got 7 parts to 15 parts, or we could write it in words 7 to 15. When we are dealing with ratios, if we're given units that are different, the first step is to make them the same. 1 minute to 14 seconds, I would not make a ratio of 1 to 14 because they're not in the same units. And so 1 minute is 60 seconds. To 14 seconds. Or we could take the units out and say it's 60 to 14. But then those, I would actually, this is something we're going to talk about in the next section, I would actually not leave it there because it's not a fully reduced ratio, just like we wouldn't leave a fraction that needed reducing. This ratio would be considered 60 parts to 14 parts. We could represent it as 60 over 14, and then of course we would reduce it by 2 and by 2, and so we could represent this with a reduced fraction of 30 parts to 7. Equivalent ratios we would talk about next. Equivalent ratios are ratios that are the same, very same number when simplified or reduced. So write an equivalent ratio. Well, you can do a number of things to write an equivalent ratio. Certainly if we just multiplied them both by 2, we would create an equivalent ratio here. We could have multiplied them both by 3. 3 by 3 would be 9, and 4 by 3 would be 12, and 6 parts to 8 parts would be the very same ratio as 9 parts out of 12 parts, or 9 parts to 12 parts, because they both reduce to a simplify ratio of 3 parts to 4 parts. Similarly, a ratio that's 24 parts to 18 parts, we could reduce that by dividing out the very same number. I could perhaps divide out a 6 and make that a 4 and divide out a 6 out of the 18 and say that my equivalent ratio of 24 parts to 18 parts is the very same as 4 parts to 3 parts. There's other ratios that we could create there, but we'll move on. 1 part to 5, we could just double it up, 2 parts to 10 parts. And of course, 100 to 250, we could reduce that by 2, we could reduce it by 5, we could reduce it by 10. Probably easiest to, let's reduce it by 10. We'll just take off those last digits, 10 parts to 25. Now, of course, that wouldn't be a fully reduced ratio, but it certainly would be an equivalent ratio. So, are the following equivalent ratios? If we take a look at the first one, 12 parts to 8, is it the same as 3 parts to 20? Well, let's write them as fractions. 3 parts to 20, 3 parts to 2. And I have to ask myself, do I get from 12 to 3 in the very same manner as getting from 8 to 2? 12 to 3 I would have divided by 4, and of course I can do the very same to get to the 2, and so therefore, yes, this is equivalent. So pause the video now and try those last 2, and then once you've got it finished, start the video up again and you can check your answers. Neither of those ended up being equivalent because neither of them had a constant multiplication factor with both their numerator and their denominator. And that brings us to proportions. What is a proportion? Well, ratios are comparisons of two numbers, and a proportion compares two ratios. This would be a proportion, finding an unknown term in the following proportion. We've actually created a proportion here that 12/8 is the very same thing as 3 halves. And so with this one, we want us to find the unknown number. So if we turn these into fractions, we can ask ourselves, well, how did I get from that 24 to the 8? We would have divided by 3. And what I would want to do is do the very same thing as top and bottom dividing by 3. And so we could say x is equal to a 10 because my 30 divided by 3 would be equal to 10. So my proportion, 30 parts to 24 parts, is the very same thing as 10 parts to 8 parts. Now some people think of these in a different manner. Some people think of these with the skill of cross multiplication. Really, it's just equation solving and moving the variable from one side to the other by multiplying both sides by n, but a lot of us think of it as multiplying up that n and multiplying up that 1.5. And when we do that, we would have 4 times my n is equal to my 10 times my 1.5. And of course we want to get rid of that n, and so we would divide both sides by that 4 to isolate my n, and I would have 10 times a 1.5 over 4, and so my n would be 10 times 1.5 would be 15 over 4, and that would work out to 3 and a bit. 3 times 4 would be 12, 3 3/4, or n would be 3.75. Pause the video and try these next two, and then start it up and see if you've found your mystery x. With this one, to isolate my x, I truly just want to get rid of this 12.5 that's dividing. So I'm going to multiply both sides by 12.5. I'll show that as 12.5 times my 0.8 over 4. And when I do that, my 12.5 times my 0.8 over 4, 12.5 times 0.8, that works out to 10. We could do that in long multiplication, don't forget that. 8 times 5 would be 40, 2 times 8 would be 16, and 4 more would be 20, and another 10. And I have 2 decimal places, so I need 2 decimal places is my answer. So my two numerators would work out to be 10 divided by 4. And so 10 divided by 4, x, there would be 2 4s in 10. And if I took 2 4s out of there, it would be 8. And so I would have 2 2/4 left over. And so, of course, that's 2.5 or 2.5. Finally, over here, 5 parts to 1 part is equal to x over 3. Let's multiply both sides by 3 to get rid of it. This is probably easier than that last one. So I'd have 3 times 5 over 1 being x, and so I get a 15 for my x. Practical application. For a new motorbike, the recommended ratio of gas to oil is 25 parts to 1 by volume. How much gas and how much oil are needed to fill a 13-liter tank on a new motorbike? Okay, it's important to realize that if we have 25 parts of gas and 1 part of oil, we have to consider the fact that those two together would be making a total of 26 parts. Out of the 26, 25 is gas and 25 is oil. And so we have our ratio of gas to oil as 25 parts to 1 part, which means we have a total of 26 parts. We've been told that we only have a 13-liter tank. And so if we take a look at my gas parts, I would have 25 parts out of 26 total parts. But I don't want 26 total parts. My gas tank only holds 13 liters. So if 25 out of 26 liters needed to be gasoline, but I'm only holding a 13-liter tank, let's put a variable there in there to hold a spot for the number we're trying to, and we could do our cross multiplication, multiply up the 13 and do our math. It's probably easier to see that the number that makes this true, 26 would go to 13 by dividing by 2, and so I want to divide by 2 to get to my x. My x is going to be 25 divided by 2, and so x is going to be 12.5. So 12.5 liters of gas. Let's figure out our parts of oil. The oil parts would be 1 part out of 26 parts, but my tank of gas, tank of mixture only holds 13. Let's call this perhaps y. And so again, I have got a situation where I'm dividing by 2. And so my y value would be 1 divided by 2, or 1/2, which would be 0.5 liters. And so therefore, a 13-liter tank would need 12.5 liters of gas and 1/2 liter of oil to maintain the proper mixture. All right, what is a rate? A rate is a comparison of two quantities with different units. If we talk about rates, we usually talk about something per something else. For example, we might talk about an hourly rate for a job. We might say I'm making $10, 1 unit, per hour, and this slash would represent hour, $10 per hour. Or if we talk about speed, we might talk about 15 meters per second, or 120 kilometers per 1 hour. And these are all unit rates, which we'll point out later because we're talking about an amount per 1 second, an amount per 1 hour, a dollar amount per 1 hour. And so all of these rates compare two quantities with different units. If we take a look at a couple of questions, Tanya earned $67.50 for working 6 hours at a rec center. What was her rate of pay? Well, if she made $67.50 for 6 hours, we would be interested in how much she is making for 1 hour, her rate of pay. Well, if we have $67.50 divided by 6 hours being some mystery value over 1, of course when I multiply that 1 up, I'm left with my variable, and $67.50 divided by 6, we would get an hourly rate of $11.25. So $11.25 for 1 hour. That is her rate of pay. A white-tailed deer can run at 13 meters per second. How far can it run in 1 minute? Well, if we run at 13 meters per 1 second, we'd be interested in finding out how is that equal to how many meters in 1 minute. Now this is a case where we have seconds and minutes, and we need to even up that unit. 1 minute would be 60 seconds, and so we'd either go to minutes here or seconds here, so let's go to 60 seconds. And so if we replace that, 13 over 1 is equal to, replace that with a variable, perhaps x, and we get 60. We can see that in order to get rid of that 60, we would multiply both sides by 60, and I would get 60 times 13 is equal to x. And so my x value, if we traveled 13 meters in 1 second, how many in 60 seconds? We would just multiply by that 60 and find out that the deer could run 780 meters in 1 minute. Sometimes we use what's called a unit rate. I spoke about that a little bit earlier. A unit rate is when we talk about this whole per 1 minute. I'm not interested in how much pay per 6 hours. I'm interested in my rate of pay in 1 hour. And very often that unit rate is used to figure out which is the better deal in a grocery store. An example here, at a fair, a 200-gram bag of popcorn costs $1. A 750-gram bag of the same popcorn costs $2.70. Which is the better value? Now, oftentimes the larger size is the better value, but not necessarily. So if we take a peek at our cost per 1 gram, our small bag, we would have 200 grams per $1. Actually, let's do that the other way around. I want to know my dollars per gram. I want to find the cost per gram. So per gram, my grams would be at the top, my $1 per 200 grams, a proportion, so a rate. We want to know how much per 1 gram. And so if we multiply up that 1, we'd have $1 divided by 200, and we would find that my cost per gram, we would have $1 divided by 200. We would have a cost of $0.005 per gram. So half of a penny per gram for that bag of popcorn. My large bag, we have $2.70 for a 750-gram bag. If I want to know how much for 1 gram, multiplying up that 1, I simply need to divide $2.70 divided by my 750 grams. I find that my cost is a little less than half a cent, 3.6 cents. So this would be 5 cents per gram. This one would be 3.6 cents. And in fact, my larger bag is the better deal, paying less per single gram of popcorn. Finally, our last question. The price of a 1-liter bottle of natural spring water is $2.19. A 750 milliliter bottle of the same water is $1.79. Express each unit price as the cost per 100 milliliters. In this one, we're not interested in the cost per 1 milliliter. We want to know the cost per 100 milliliters, and that's what you'll often see in the comparison sticker in the grocery store. And so my first 1-liter bottle we have $2.19 divided by my 750 milliliters. I want to know what is my price for 100 milliliters. And so I would multiply up that 100, multiply it on both sides. Multiplying on this side would cancel it out. So I would get 219 over 750, and 219 over 750. Oh, sorry, this is a 1 liter bottle. Hello. It's getting late and I'm getting tired. We'll change that up. I apologize. 1 liter. We need to change to milliliters to compare it. 1 liter would be, of course, 1,000 milliliters. And here, I likely wouldn't have multiplied up. I would have canceled out. My 100 goes in here once and in here 10 times. And so I have 219 divided by 10. And so my x dividing by 10, we would just move our decimal one place to the left. We would have 21.9 cents or $0.0219 per 100 milliliters. My 750 milliliter bottle, we are paying 179 cents or $1.79 for 750 milliliters. And I want to find out how much is 100 milliliters going to cost me. So again, we'll multiply up that 100 to isolate it away from my x. And we would have 179 over 750. And again, this is B1 where I would likely be using a calculator. 179 divided by my 750, and I would find out that my unit price if I was to round that to the same number of digits as my other one, it would be 23.9 or 23, so dollar value or 23.9 cents per 100 milliliters. And so if our comparison shopping, if we were taking a look, this one would be the better deal where we're paying less money for every 100 milliliters. Now, we have quite a number of homework questions that are available for practice problems for this section of our course. And I would suggest to do only every other one of them. The even numbers would be quite enough practice on this section.